Okay, let's jump into it. Try to move quickly, get out of this algebra section. We're going to continue with 1.1. So last time we spoke about functions, and we spoke about what a function is, some ways we can represent it, how to find the domain, vertical line test, piecewise function. We spoke about the absolute value graph. Now we're going to talk about symmetry. Two important types of symmetry we care about. And especially when you get to calculus 2, you see why we care about these so much. The kind of symmetry presented by even functions. These we're going to talk about one by one. So let's talk about the even function and what kind of symmetry it has. Call a function even if it's symmetrical about the y-axis. An example of such functions are things like y equals x squared. Graph looks like this. Notice that it's symmetric about the y-axis, meaning if you take the right side of the y-axis and reflect it in the y-axis as if the y-axis were a mirror, you get the left side. Right? Or y equals cosine of x, which was actually on the quiz. Put the number over here. So cosine looks like this. That's one here, but if you trace the other side, you'll notice that the left side is the mirror image of the right side. Right? Yes, it is a symmetry. Right? What's the maximum point? 1. Where is this? This is pi over 2. Where is the minimum point?
3 pi over.
It's pi. What is the minimum value? -1 here.
3 pi over 2.
This is 3 pi over 2, and the peak here is 2 pi. Right. But the thing with cosine is if you reflect it over the y-axis, it is actually fall right over itself. It's symmetric about the y-axis. Even functions have the property that f of minus x is equal to f of x. Meaning if you replace all the x's in your function with minus x's, it makes absolutely no difference. You get back the same function. So for example, if you have f of x equals x squared, then you will notice that f of minus x will be equal to minus x squared, which is just the same as x squared. Right? Or if your f of x is cosine x, then your f of minus x is just cosine of minus x, which is just cosine x. Right? No matter what x value you pick here, right? Like if I pick the pi over 4 here, the y value would be what? Cosine of pi over 4 is what? Radical 2 over 2. If you picked minus pi over 4, you get exactly the same value, radical 2 over 2, right? Whether x's are positive or negative, it gives you the same value. And what happens with the graph is it will be reflected about the y-axis whenever this happens. Odd function. functions. These are functions that are symmetric about the origin. That just sort of means if you take the right side, reflect it over the y-axis, then reflect the result over the x-axis, then you get the left side. That's sort of what it means. An example is the function x cubed. It's an odd function. It looks like that. So if you take the right side, flip it over here, you'll get something that looks like that, and then you flip it under, you get that. Functions that behave this way are called odd functions, and you say they're symmetric about the origin. Sort of rotated about the origin 180 degrees, and you get the other side. Another function is sine of x, is actually an odd function. So if you had sine on your quiz, you would have drawn something like this. Notice that if you continue the pattern, it would go like that. This is at 0. Again, the maximum is 1. The minimum is -1. The peak happens where? Pi over 2. 0 at pi. The minimum happens at 3 pi over 2. And it hits here again at 2 pi. And this is an odd function. If f of x is an odd function, then you would have that f of minus x is actually equal to the negative of f of x. So example, again, if my f of x equals x cubed, then notice that f of minus x is just minus x cubed, which is the same as minus x cubed, which is the same as minus f of x. Or if I have f of x equals sine x, then your f of minus x is just sine of minus x, just minus sine x, which is minus f of x. Right? Notice that here, pi over 2 gives me positive 1, but if I looked at negative pi over 2, that would have given me negative 1. Gives me the negative of what it was on the right side. Right? So if I make the x negative, I make the whole function negative overall. Functions that behave that way, we call them odd functions. Of course, there are functions that are neither even nor odd. A simple example would be something like the function x cubed plus 1 is neither even nor odd. Or you know, if you take f of minus x, that's just minus x cubed plus 1, which is 1 minus x cubed. And notice that this is not the same as f of x, and it's also not the same as minus f of x. Right? It's neither of these functions. So this guy does not have symmetry about the y-axis nor the origin. If you were to draw the graph of 1 plus x cubed, it would look like that. Turning through here at 1. You notice if you reflect this part over the y-axis, you should get something looking like this, but it doesn't. And if you reflect that over here and then over the x-axis, you should get something down here, which you don't. This is a function that's neither even nor odd. Questions on this? Just sort of a definition. We'll use it more later on, and you'll use it even more in calculus too. Because when you get to taking integrals and finding areas and things like that, knowing if a function is even or odd can make the problem a whole lot easier. So it's always something you look out for. Another definition to finish off this section is increasing and decreasing. For now, we'll do the definition. We'll come back to this later on when we have more equipment at our disposal. But for now, you can just look at the definition. A function is increasing. If x2 is bigger than x1, when x2 is bigger than x1, for all x1, x2, and that's the definition of increasing. Let me illustrate what that means. Basically, that means in all cases, like say my interval is this guy. That's my interval I. And here's an x1, and here's an x2 that's bigger than the x1. Then my function value here, the f of x1, if it's smaller than the function value for f of x2, for all x1 and x2, it means that your function is increasing. Graphically, that means as you move from left to right, you're going up. Right? That's sort of the idea behind it. Of course, decreasing means the opposite. You're going down as you move from left to right. Again, looking at the interval I. If any two random numbers x1 and x2, where the x2 is bigger than the x1, then the function value for f of x1 would be higher than the function value for f of x2. And that means your function is moving down as you go from left to right. Any questions on the definition? So that's even and odd functions. You know how to recognize it from the graph and from equations, and this is increasing and decreasing. You know how to recognize it from graphs and the equations. And we're going to come back to this, and we're going to analyze things in terms of increasing and decreasing all the time in a very nice and systematic way. This is just introducing some definitions. And that actually completes section 1.1. So the homework for that is due on Thursday. Section 1.2. A lot more definitions and refreshers. We're going to look at some essential functions. So these are the functions we're going to do most of the work with in the class. Polynomials is one class of functions we're going to deal with all the time. It's They're among the nicest possible functions you can ever have in a calculus class. They behave very well, and we're going to see this later on. Their domain is everywhere. Right? Their range is usually easy to figure out. They're continuous everywhere. We'll talk more about what continuous means. They're differentiable everywhere. We'll talk more about what that means. They're integrable everywhere. We'll talk about what that means. So pretty much anything we want to do in calculus, polynomials allow us to do it. They're really nice functions. And they behave relatively well in regards, well, in comparison to other functions. Definition. Those are polynomials.
Multivariable expression? Is it a multivariable expression?
Explain.
Like you have more than one kind of term in the whole sentence?
Can you give me an example of a polynomial?
X squared plus 2x plus 2.
Sure, that is a polynomial. So we want to define that a polynomial is a finite sum of terms. Well, in this class, we only care about single variable polynomials, so let me write that down. In Calc 2, you're going to deal with multivariable, right? So there's a multivariable is actually a very technical term. That's why I didn't want you to use that. Is a finite sum of terms. C is a constant called the coefficient of the term. A is a non-negative integer. Hence you have that a polynomial, a general form for a polynomial can look like a0 plus a1x plus a2x squared plus anxn. This is a general form. Right? And this is called the nth degree polynomial. the power of the fraction, and it's also negative, right? So it's also true that something like 2x to the minus 2 plus x plus 4 is not a polynomial either because of the negative power. The powers have to be non-negative, or all bets are off. See, things with negative powers cause trouble. Why can they cause trouble if you have a negative power? Yeah?
Because to solve it, you need to put it over on their own, right? So then it will become a whole different thing. And you want to solve it with basic zeros.
Right, so it means you have a situation where if x equals 0, for example, here, everything messes up. Functions like that don't behave nicely. Polynomials of that form, they behave very, very nicely. Right? There's nowhere you divide by 0 or anything like that. So you can rest at ease when dealing with polynomials. So they're very nice functions. And at some point in the class, you'll learn how to graph various different types of polynomials. That was going to be pretty tough. Some special times that you should know. There's a linear polynomial. So sometimes we'll actually use these words. I'll say, use a linear function to do this. This is what I'm talking about. This is a degree 1 polynomial. So it's of the form a0 plus a1x. So whether x equals x plus 1, or y equals 2x plus 4, or what are the graphs of linear polynomials? Straight lines. Right, so y equals mx plus b, that's talking about a linear polynomial. Right, so your lines look like this. Right. So that's a line with positive slope. Or you can have a line with negative slope. You can have a line with 0 slope. You can also have a line with slope undefined. Okay. So these are all graphs of linear polynomials. The graphs are straight lines. Another guy that we see all the time is a quadratic polynomial. These are second degree polynomials. So the form is f of x equals a0 plus a1x plus a2x squared, where a2 is not equal to 0. And of course here the a's are constants, right? I mentioned that before. All the a's are constants. Which we call coefficients. And the graph of a quadratic is a what?
Parabolic.
Parabola. So parabolas look like this. Or go upside down. Right? Looks like either a smiley face or a frowny face. These guys are, here it's where your A2 is positive, it will look like that. When your A2 is negative, it will look like that. And again, you learn how to graph these guys. I'm not going to go over that. Just remind me what they are. It's supposed to jog your memory a lot. So now that I introduced these, I expect you to go over, and if you don't remember, right, make sure you know how to do the y equals mx plus b thing, how to find the equation of lines given 2 points, how to find the equation of lines given a point and a slope. You should also know everything that falls into here, like ways how to factor these, how to use completing the square, how to solve by factoring, how to graph them. All that you should remember because we're going to be using it. Another important kind is cubic, polynomial. This is a third degree polynomial. So this is what a cubic looks like. So, the graphs sort of look like either a badly written S or they could also look like N's, something like that. In general, what you'll realize with polynomials, and this is something that you saw in pre-calc, is the highest power, you can have at most one less term than that power, right? So a cubic can have up to 2 terms, right? A hill and a valley. You can never have more. Once you have more terms, you have to increase the power. So that's something you learn in pre-calc. Any questions so far in any of this? Like we've all seen this before. Just want to jog your memory, but know that I do expect you to go and fill in all the details of things that I haven't said, because it's really important. But it's very important for you to recognize at a glance when you're dealing with which type of function, because it's going to give us a lot of intuition into how to do these problems, especially when we get to limits, which is a pretty important topic. We'll stop there for now. So 1.1 homework is due on Thursday. We haven't finished 1.2. So.